Okay, so today we're talking about section 8.2, which, as I mentioned last time, is all about the student's T distribution. All right. So, this is another distribution that's very similar to the normal distribution. It's symmetric, right, for one. And the book has some far better pictures to sort of show what the difference is, but it's symmetric about 0, and it's defined by, right, so that first one is a way that it's similar to the normal, but this one is defined by its degrees of freedom. All right, so there's no mu or sigma to worry about here. It's just how many degrees of freedom does it have. And how we get the degrees of freedom and everything, that'll come up when we talk about it next section. But we're mostly going to be worried about finding critical values. All right, so this degrees of freedom is called df. So we're going to be finding values that look like T sub alpha, comma, df. Right, so these are a lot like the Z sub alphas. Right, well, last time we were talking about Z sub alpha over 2s. But Z sub stuff, right, is the critical value. So one way we can find this is to do inverse T. You put in alpha here, and you put in the degrees of freedom, right? So that's one way to find it. The other way is to use this table. So I'm just gonna zoom up to here. I'm not sure what the one in the book looks like. I don't actually have it here with me. But you might want to look one of these up on your own, and I wanted to sort of point out some of the things you'll get from it. One thing, other places have different... Oh, I know what's going on there. Let's move this to there. Haha, fixed. So other places have different notation for degrees of freedom, but they will always tell you what it is. So here, when it says V degrees of freedom, that's just going to say that when we're looking for DF, we would call it V on this chart. And the other thing to notice is that this is a right-tailed table, right? So the value that it's looking at is over here on the right. So this is, as it says here, giving us probabilities of being greater than. But we can always do 1 minus if we want to do a less than probability. Usually, well, we'll talk more about that when we're actually at problems where we're going to use it. But, for instance, if we wanted to find T sub 0.1, comma, 20, right, we're going to look at this column and this row, and we're going to get this number. Right, maybe we want T sub 0.005, comma, 7. Well, we're going to look for 0.005 in the alpha, and we're going to look for 7 in the degrees of freedom, and we're going to get to 3.499. Right, so most tables that you'll look at for the T distribution are going to give you things like this. And when we wind up wanting it, then we'll talk more about how we need it. But this whole section is about how you use the table. notice that in the book, when it has table, like in this section, I do remember this from the section mostly talks about left-tailed tables. But it turns out that it works out to be the same values because of that symmetry about 0. So this is the whole section. It's about how to use this table. Remember that there's always your calculator option as well, if you don't want to lug around a table with you. But yeah, that's what this section is about. And next time we'll go back into the confidence intervals. And really next section is going to be pretty much entirely a repeat of last section. Right? So 8.3 is going to be just like 8.1, except instead of finding z sub alpha divided by 2, we're going to find t sub alpha divided by 2. That's it. That's the difference. We're done. But we will be talking about that next time.